Hi, and welcome to our discussion of weather information. In this video, we're going to talk about flight information services. And flight information services are one way of getting weather information and also aeronautical information into the cockpit. And the reasons that we use flight information services is because it helps us with our situational awareness. Also, it gives us the tools we need to make the decisions and also helps with the safety of our flights. So, flight information services provide additional information and augments the typical method of getting weather information from flight service stations and also air traffic control. That would be over the radio using voice communications. So it's not really intended to replace flight service stations or air traffic control information, but to augment that and help us kind of refine what kind of weather information we want. So it provides us weather information. We can parse through that data and then ask flight service station air traffic control for more information or for suggestions. The way flight information services works, there's three different modes. Datalink modes. This is data link into the cockpit. There's the broadcast mode, which is currently in use. It's called FISB or FISB. There's also contract demand and contract update modes. The broadcast mode or FISB is only one way. You've got ground transmitters that are continuously broadcasting information to aircraft. If you have an aircraft with a receiver and a way of displaying that information, you're able to look at that information and use it. And that is what the FAA is providing us today. It is operational today. There's also two other modes, the contract demand mode, where an aircraft transmits information, or a request, I should say, to a ground transmitter, and it sends the information back up. And another proposed method is the contract update mode, where it is similar to the previous one, where it sends out a query or a request. But in this case, it's continuously updated. The updates are automatically sent. So flight information services, of course, just like internet, has to have a provider. So we have different providers that provide data link services, and what they do is, of course, they maintain the infrastructure. So they may have a satellite that's up there providing this information. They may have ground-based transmitters. They may charge for these services, or it may be free. Go through a couple of different service providers. The first one will be the FAA, and their system is part of ATSC. It's called FISB. FISB stands for Flight Information Service Broadcast. It's one way. It's coming to your aircraft continuously broadcast from ground transmitters. This is, of course, the ATSC network that has been in place for about the past decade. They use UAT 978 megahertz transceiver, and typically this information can be received if you have visual on a transmitter. In other words, it's line of sight. Similar to VORs, you have to have line of sight to be able to pick up a good navigational signal. Same thing with FISB information. You have to be at high enough altitude and be able to see the transmitter line of sight to be able to get that information. There are also service providers for this data link service that are not FAA, and they charge for their services. These are commercial vendors, and two of the more popular ones are the Weather Company, or WSI is the Weather Company, and also XM Weather, which is provided for subscription by SiriusXM. To be able to get data link information, you have to have an aircraft that's equipped with a receiver. In other words, you have to have an antenna, some way of decoding the information, and then also displaying that information. This information is both weather information and also aeronautical information. If you're getting this information from ground transmitters provided by the FAA, this information is free of charge. FISB is free. So, as I mentioned, typically you have to have a transmitter to provide this information, a receiver in the aircraft, and then some way of displaying that information. Here is the FAA's network all across the United States. They have transmitters all across the U.S. Providing FISB and also TISB for traffic information. What they have at their website is a display or a map of the service volumes of their ground transmitters. And of course, the higher you get, the farther you can receive a ground transmitter. So at higher altitudes, it's almost seamless across the United States, flying from one part to the other. You're almost continuously in FISB service volumes, except when you get, of course, out west, where you have mountains and terrain obstructions and other things like that. This is just kind of a schematic of how the weather information flows, taking, for example, just radar, looking at radar. Weather radars, of course, are ground-based. There's a network all across the United States, the WSR-88Ds, or NEXRADs. We call those NEXRADs. That weather information goes to the National Weather Service. The National Weather Service provides that information free to vendors. The FAA has subscribed with a vendor to format that data so that it does not take up much bandwidth, and it transmits quickly to a ground station, which transmits that information to the aircraft. The service provider, or not the service provider, but the, well, I guess the data provider is the weather company or WSI. They're the company that reformats that information and packages it so that it can be transmitted by the FAA's ground-based transmitters. There is a volume of information that is being broadcast continuously by these ground transmitters. And it's basically all the weather information that you need, including METARs, specials, TAFs, pilot reports, winds aloft, special use airspace, temporary flight restrictions, SIGMETs, convective SIGMETs, AirMets, NEXRAD, the National Weather Service radar. You can get that displayed in the cockpit, but they only provide composite reflectivity and not base reflectivity. And then also NOTAMs. You can get NOTAMs while airborne. You need to be aware of the limitations of the FAA's FISB system, and those two limitations are the update interval and the transmission interval. The update interval is how often weather information comes from the provider, in this case WSI, so that it is available to be transmitted. So in other words, how often do they send METARs and other National Weather Service radar information? How often is that available from the service provider? And then the transmission interval is, once that information is at the ground transmitter, how often is it transmitted, broadcast by the ground transmitters. Here is a chart. This is straight from the Aeronautical Information Manual. Actually, it's not a chart, it's a table. And it has all of the update intervals and also transmission intervals. So update intervals are how often the information comes from the service provider, and transmission is, of course, how often it's transmitted by the ground-based transmitters. Also, the higher you go, the further the information you will see ahead of you. This shows a table, once again, from the Aeronautical Information Manual that shows information whether you're at low altitude or high altitude. The higher you go, the further out you can see information. And of course that makes sense. If you're flying at high altitudes, you're going to be flying probably a jet, which travels at a very great speed, so you want to see farther ahead of you. If you're flying at lower altitudes, then you're typically a smaller aircraft and you're flying a lot slower. Here are some pictures I took on a flight that I took across the central United States. There's lots of different things that you can plot. Of course, if you are getting METARs, you can, some software packages, and in this case I'm using ForeFlight, will allow you to plot the surface winds. In this case, I was kind of curious where the cold front was, and I was wondering if I was going to pass through the cold front as I was flying northward. And you can see the wind switch around from the south to the north along my route of flight. So I'm going from a tailwind to a headwind in this case. Also, you can see the composite reflectivity from the NEXRAD radars plotted on this. You can see it's kind of blocky. It's not the greatest detail because of the bandwidth. And here's a little bit of close-up of another flight where I'm flying across, once again, the Midwestern United States. On this particular day, there were thunderstorms, and I was concerned about that. In this case, the thunderstorms were a good distance apart, more than 50 miles apart. So I felt safe to be able to fly in between those and navigate along this route of flight. So, of course, we talked about the limitations of the system. Remember that there is perhaps some latency as a result of the interval and the transmission times. Remember that this shouldn't be your only source of weather information. You should also contact flight service stations and air traffic control to provide weather updates for fast changing weather events. The FISB helps you digest the information. There's a lot of information, gives you some time to look at it, and helps you figure out what you want to ask from flight service stations or from air traffic control. With that, the caveat is this information should not be used for tactical severe weather avoidance. In other words, you really shouldn't use this like an airborne weather radar. If you're trying to make decisions, within 3 or 5 minutes, that's tactical. You're trying to pick your way through lines and that's cells, and that's not good. Instead, you should use it more strategically, meaning looking out forward, trying to figure out how to avoid large areas of thunderstorms. And if they have big gaps between them, if they have big gaps, then you could probably circumnavigate around those more easily. Also remember that this weather information is only available as long as you're in a line of sight of a ground-based transmitter. If you're at low altitude, you're not going to pick it up as easily as if you were at high altitude. Also, if you're just happen to be at an airport that has a transmitter, it's your lucky day because these transmitters are not at every airport, and sometimes they're not even located at airports. And remember that there's a lot of information that's coming in, so you have to digest that, and it can kind of be overwhelming and kind of help saturate you. In other words, it can affect your cognitive workload. So you probably want to help reduce the amount of information, be strategic as far as what you're looking at. Don't look at everything, just try and figure out the things that you need. And of course, always use other sources than just FISB. And that's kind of an overview of flight information systems or services that are broadcast. And I hope you enjoyed that.